Good evening. Namaskara, everyone. ಹೇಗಿದ್ದೀರಾ ಎಲ್ಲರೂ? Let me know quickly in the chat box if you guys are doing great and if I'm audible, visible to all of you. Yes, Namaskara, Saujanya, Samuel, Latha, GM, Yash, Study of Success. Good evening. Today, I'm going to give you a passing package, basically for those students who feel that I will get very low scores. So this package will help you boost your score. 100% you will pass from this particular package. Also, if you are getting very low marks, maybe you will just pass. So from this passing package, your score will be additionally boosted. Okay, so that is what this entire video is all about. I'll give you the model answers, everything. We'll discuss what to write, all those things in today's session. Okay, so yes, my name is Captain Shreyas, your physics master teacher on the Vedantu Karnataka, Namma Karnataka channel, and I hope you guys are doing great. Hi, Unnati, Amulya, great Saujanya, awesome. Hi, Slayer, welcome aboard. And yesterday I was just going through the channel, and then I noticed one very interesting statistics in our analytics. Oh, by the way, we have a lot of students from all the parts of Karnataka. That is one very good thing, and I'm really happy about it. I want this channel to be popular to every nook and corner. And of course, where I'm right now conducting my classes from Namma Bangalore, oh my God, so many kids. So cool, guys, to know this. So first of all, very important thing, many students have not yet subscribed to the channel. You are watching the videos and you are not subscribing. It tells you are, what is this? You are conjuice, or maybe you are just not bothered, or maybe you have just forgotten for some reason. Whatever the reason is, guys, don't do that. When you're watching these videos on this particular channel, when we are doing so much, you're watching it so many times. So the one thing that we ask for is liking the video and subscribing. So please do that. Make sure that you are loyal, make sure that you are connected, make sure you are getting all the relevant updates, and we never spam you with anything. So it's all academic content purely. Okay, yes. So let's begin with the class. And I would also tell you that we will be conducting a special numerical class, like mentioned and asked by many students tomorrow. Tomorrow, there will be a numericals class. Okay. Okay. All right. Great. So let's begin with the class. The passing package will include three main units: electric charges and fields, electrostatic potential and capacitance, and current electricity. These three units alone, even if you see whether the blueprint 1, 2, or 3, whatever you take, okay, easily you will be getting 30 marks, 35 marks, 33 marks around that particular score in these three chapters alone. So if you get 30, 33 marks, and in your practicals 100%, you will be getting close to 25 to 30 marks. So easily you will score 60 marks, assuming you have got close to 30 marks in your practicals, which is very likely. No invigilator, no school will try to put down your marks unless you have done a lot of mischief out there. So hopefully with this particular passing package, you will cross easily above 50 marks and maybe close to 60-65 marks. Okay, so let's begin with the electric charges and field related questions. Define SI unit of charge and what is the properties of charges. Okay, when I say charge, symbol Q, the SI unit of charge is basically Coulomb. Yes, it is basically Coulomb. All right. And I'll just put it over here. The SI unit. What is the SI unit of charge? It is basically Coulomb. The shorthand for symbol is C. Okay. Q is the symbol for charge. SI unit is Coulomb. And you should also give an example like, one electron. For an electron, the charge on it is 1.6 10 to the power negative 19 Coulomb. Just for the sake of example, that is the first thing. Next, what are you going to write? The properties of charges. What are the 3-4 major properties? See, sometimes they can ask you 3, sometimes they can ask you 4 properties or 5 properties also. If main properties are, first is it possesses additive property, meaning the total charge is Q1 plus Q2 plus Q3. You can just add the charges. Second thing, charges are quantized. That means the total charge is a number multiplied by E, either positive or negative. So 1E, 2E, 3, 5E, 6E possible, 1.7E, 2.85E not possible. So always integer types, it is in quanta. Quanta means a number, it is always a multiple of that number. Third thing, they are always conserved. Okay, that means you can never create something or destroy the charge. That is the third point. So if more properties are asked, you can add more properties, things like you can say it's a scalar quantity. It is a scalar quantity. The fifth point can be the unit and the dimensions. The unit and the dimensions, by the way, the dimensions is ampere multiplied by time. Ampere multiplied by time. So these many things are more than enough if it is a slightly bigger question, maybe for 2 or 3 marks. Okay, is that clear? Yeah, numericals are also very likely to come from current, electricity, capacitance. In fact, there is a special session only on numericals tomorrow. Okay, it will come up very soon. Next, state and explain Coulomb's law. Give the vector form of Coulomb's law. This first question done. Give me a thumbs up, guys. Give me a thumbs up. Everybody done? The class will be barely for 1 hour. Okay, not more than that. Okay, because it's a passing packet, we can't keep it more. Okay, state and explain Coulomb's law and the vector form of Coulomb's law. Coulomb's law is basically the law which tells you about the force of attraction and repulsion between two charges separated by some distance. It's an inverse square law. So the force of attraction or repulsion between charges is directly proportional to, what is it directly proportional to? The product of the magnitude of the charges, Q1, Q2, it is proportional to, and it is inversely proportional to the square of the distance. So directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance. So the constant of proportionality is 1 by 4 pi epsilon naught. You can see this is the constant of proportionality. It is also called as the Coulomb constant. It is also called as the Coulomb constant. And yes, the value is 9 into 10 to the power 9 in SI units. You can mention that, you will get full marks. That is the first part of it. What is the vector form? In the vector form, what you should write is that the force vector is the same thing. This is the magnitude part, 1 by 4 pi epsilon naught q1 q2 by d square. Just put a unit vector. Just put a unit vector r hat, where r hat is a unit vector in the direction of the force. So that is just the vector form. Whenever you have a vector, you have magnitude and direction. This part over here is the magnitude. This part gives me the direction. So r hat is the direction. Added bonus will be given. I mean, you will impress the examiner if you show the diagram. So you show the diagram, charge 1, charge 2, force, distance d. Please show diagrams in every question, because see, you have to pass, you have to impress. What do you do when in movies heroes have to impress the heroine? They do everything possible, right? So think, you have to impress the heroine. Who is the heroine? Your examiner. Okay, so or vice versa, you have to impress the hero if you're a girl. So try everything possible. You will dress up properly, you will pull up all the stunts. So here you cannot do all those things by dressing up. You have to make sure every possible thing that you know, you write it down. But see the marks for the question. If it is 1 mark question, don't write one big 1 page full answer. Right. Next, derive the expression for the torque electric dipole placed in a uniform external field. Okay, for torque on an electrical dipole. So in that, first comes the diagram. First comes the diagram where you show that particular dipole. You show the electric field going in this particular direction, and then on the positive charge, you show the force on this side. On negative charge, you show the force on this side. This diagram also needs the angle over here, one negative charge, one positive charge, and the distance between them will be 12. All these things are important. Okay, all these things are important. Everybody understood till here? Okay, so the length, the negative charge, the positive charge, the force, and the electric field, and the angle. All these things to be shown in the diagram. Next important thing, remember the exact opposite. Remember your final answer. What is your final answer? Final answer is of the torque. Torque is P into E into sine theta. That is the magnitude. But in the vector form, the torque value will be P cross E. That is the vector form. Torque is basically P cross E. That is basically the vector form. So the magnitude form is P sine theta. Somehow you have to get there, where P is nothing but the dipole moment, which is charge into the distance. So any one charge multiplied by the distance, which is nothing but 2L, that is your dipole moment. So if you want, write it in the reverse order. That is a smart way of doing the same problem. Sometimes when you don't know how to, sir, get here, go reverse. It's okay. So you can just say, oh, torque is P into E into sine theta, but P is charged into 2L. Oh, so now you understand. Fine. So torque is field charge 2L sine theta. What is this 2L sine theta? This 2L sine theta means this distance, which is right over here, which is the distance between these two forces. And that is how torque is. Torque is always the force multiplied by the distance between the forces. So the force which is there multiplied by the distance between the forces. So you can also go reverse when you do not remember the derivation, and then suddenly you will be like, yes, this is the starting point. So start only from here, you can go up like this. In case you do not remember, but if you remember, of course, please go like this only, because you do not know how much space you will need. Not just that, you have to also mention where F is the force is charge into field, all those things. All these initial things you need to mention. You mention about couple force. So what is the meaning of couple force? Couple means two equal but opposite forces separated by a distance is a couple. The forces cancel, but the torques are going to be created. So a couple will always create zero net force, but it will always create a torque. That is the meaning of a couple, and that is exactly what a dipole will do. Is that okay? Absolutely clear? Very good. Awesome. Awesome. Okay. Very good. Then the next important thing, give any three properties of electric field lines. Electric field, many properties are there. Number one, you can say it always starts from positive and it ends at negative. Standard. Starts from plus, ends at minus. They will never intersect. This is another important line. They will never cross each other's path. They will never ever form a closed path, meaning starting and ending at the same point. That is not possible. Okay, it will always start from somewhere and end at somewhere. It will never start and end at the same place like a closed loop. That is not possible. Okay, next, they will not pass through a conductor, meaning electric field inside a conductor is zero. In fact, from the surface of the conductor, the electric field lines are always going to be perpendicular. They are always going to be perpendicular, but they are never going to be inside the conductor. Also, when the field lines are parallel to each other, then such a field is called as a uniform field. So when field lines are just parallel to each other, that is uniform field. This is another property which you can mention. If they ask you any three, just give these three properties, more than enough, or you can give the first two and this. So first two are the most important, positive to negative, and they cannot intersect. These are the two most important things. The third property can be either this or this or this. Any one of them you can give, you will still get marks, but better to give one extra property just in case. I hope this is clear. Okay, awesome. Can we write r square instead of d square? Yes, definitely you can write. No problem. No problem at all. Distinguish between polar and non-polar molecules. Give the examples of polar and non-polar molecules. Polar means there are polarities. Non-polar means no pole in that. So molecules like water, carbon monoxide, NH3, all these things, they are polar molecules because there are two elements of different kinds. So what happens? The electron cloud will shift towards one of the atom. So for example, we have HCl. HCl. So H will become positive, Cl will become negative because the chlorine molecules are going to attract those electrons. So there is a polarity which is created on hydrogen and chlorine. Same thing with H2O, carbon monoxide, etc. The cloud of electron is going to shift. So that is the reason why they are called polar. But when you have elements of same kind, then there will be equal distribution. So nothing is positive, nothing is negative. The positivity and negativity is at the same place. It's like twins. So all these things are like twins, except for few things like CO2, because it is a linear molecule. What happens is, there is no net polarity as such. But other than that, all these other molecules, they have polarity. So polar molecules in which the centers of positivity and negativity coincide. So there is no separation between positivity and negativity. It's called polar. Examples: H2O, different atoms. Okay. Non-polar means no net polarity, because the positivity and the negative centers are going to coincide over here. Examples like twins, O2, N2, H2. All these are examples of non-polar. Okay. I hope this is clear. Yeah. Passing package enough to score 70? No, 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 Ganesh. How can you get 70 with passing package? See, now you are becoming greedy. You are asking for passing package. How do you pass at 70 marks? So, understand, 30 marks approximately you will get in practical. Okay, worst case 25. Okay, just take worst case 25 marks. So, fine, from passing package, let's say you get 30 marks. So, 25 plus 30, that's 55 marks. That's what you can expect. Okay, but assuming you are learning the passing package properly, all the questions, all the numericals, all the definitions, you have to do it. Derive the expression for torque on electric dipole. I think this question was before. It was, again, it just got repeated. Sorry, guys. This one. Derive the expression of electric field due to a dipole on the axial point. You can also get equatorial point. So basically, things where you have a dipole, this is the axis, this is the equator. So this is the equator. At least you should know the formula for the electric field on the axis of the dipole. At least that. The formula is electric field is equal to 1 by 4 pi epsilon naught dipole moment by r cube. And here you have basically p bar. So it is in the same direction as the dipole moment. That's how it is. So the dipole is placed in this direction and this is the distance. So at this point, the electric field is exactly in the same direction. So that is the reason for it. So at least know the formula and the diagram. Now, making the derivation part, I'll tell you what you can do. At least write the first few steps. See, I'll tell you, even if you do not know all the steps, no, it's okay. You can miss some steps. You can fool around that examiner little bit. How? Positive, negative, you write. You show the distance is basically 2L. You say this distance is basically R. Okay. And at this point, you want to find the electric field. So due to the positive charge, there will be an electric field like this. Okay. And that formula will be nothing but Coulomb's constant charge divided by this much distance, R minus L. So this will be basically R minus L whole square. Is that right? Because this much distance will be R minus L. And the reason why I'm putting R minus L is because this much distance is only L. L plus L will make it 2L. So R minus L is this distance. So that will be the field. Similarly, there will be a field like this because of the negative charge. Of course, this whole distance will be R and plus L. So this will be R plus L from here to here. And that electric field will be Coulomb constant charge divided by R plus L whole square. Now you know that your total electric field will be this and this. They will oppose. So it will be subtract. So just put this thing E plus, which is nothing but KQ by R minus L whole square, and again put over here E minus and then put KQ by R plus L whole square. Then put minus sign here, then put equal to here. Now just do whatever calculations you want. Even if the calculations are correct, wrong, it's okay. If you are not remembering it, just do it naturally, go with the flow. But your final answer should look like this. Charge into dipole moment means Q into 2L, the whole thing divided by R cube, and then you will say K into charge into 2 into length is nothing but the dipole moment divided by R cube. Here you can say approximately, using approximations we get this. So I know there are a lot of steps in between, but I'm showing you the main steps over here so that at least few things you will remember. Rest of the things just solve. No, open the bracket, expand it, take LCM, neglecting this term, neglecting that term, blah blah blah. Something you do. Okay, at least get those marks. Got it, my dear students? Don't leave the answer. Don't leave it. See, worst impression you can give is you write till here, you know the final answer, but you don't complete the problem. Then it is 100% seen that you have not completed the derivation. But imagine you write something, some expansion, some LCM, something approximately taking, you confuse. When you can't convince, what you should do, confuse. What did Shreyas sir say? What did Captain Shreyas sir say? When you can't convince, you should confuse. So write all those things and then, okay, then this is the answer, and then finally this is the answer, and block it off. Oh, hence the field formula is this. And actually, you should get 2 times. My bad, I forgot that number 2. So sorry, guys. The formula has that number 2 over there. I forgot that 2. On the equator, there is a no 2 over there. So when you get that, examiner will be like, okay, something he has done. I don't have time to see each and every step. Okay, I will cut half a marks because I'm not able to understand clearly. Or 1 mark they will cut. But they won't cut full marks. Or they won't cut many marks. So that is very important. Understood? Clear? Yeah, very good, very good, very good. Cool. So that is how you should do this, my dear students. Then this particular thing. State Gauss's law in electrostatics. Using Gauss's law, derive the expression for the field. I've done this in the derivations class also. Now, I don't know how many of you have seen the derivations part. See in the videos, I have done all the derivations, all physics derivations. Over here also, I've done it. So watch that explanation. So this is another important question. Yeah, this is another important question. Okay, then this is done. State Gauss law, obtain the expression for field due to a uniformly infinite long wire. This derivation also I have done using Gauss's law. State Gauss's law means, yes, Gauss law is nothing but the total flux through a closed surface. The total electric flux through a closed surface is equal to 1 by epsilon naught into the charge which is inside. So write that formula. You will get full marks for that definition. Then you have to derive it. And the formula is lambda by 2 pi r epsilon naught. Lambda by 2 pi r epsilon naught. If you remember the final formula and if you remember the initial Gauss law, in between you have to fill up the steps. The diagram is something like this, where you have a line charge, you have to show a cylinder. Yeah, check out the derivations video, it is there. Check out the derivations video, it is definitely there. Okay, then next, infinitely long sheet. That derivation also very important. Sigma by epsilon naught. That is the formula for that particular field. Yes, sigma by epsilon naught. That is what you have to use. Yes, sigma by epsilon naught. And this number 2 will also come over here. When it is a sheet, then the field will go both ways, so that number 2 will come. That's how you remember that number 2. The field is going both ways. Both means 2. The number 2 will come. So sigma by epsilon naught and that number 2. Yep. This is another important derivation. Next, electric dipole torque. I think we have done this. Okay. Sketch the electric field lines due to a point charge if it is positive and negative. Another important question. For positive, it is going to be outwards. For negative, it is going to be inwards. Yes, this is another important question which they can ask. They can also ask for a dipole. Yeah, dipole, or even equally charged charges. So if it is a dipole, then it will originate from positive, come to negative, positive to negative, and show equal number of field lines coming from positive to negative. If it is a repulsive field, then they will not intersect. They will try to run away, as if they do not like each other. They will try to run away from each other. All these 4 diagrams, very important. Please practice them for passing package. Define equipotential surface. Equipotential means all the points with the same potential. Okay. Example, you can say, if you take a point charge, the shells become the equipotential surface. The shells. Any 2 properties, you can say no work is done to move a charge over the equipotential surface. Yep, no work is done to move Yes, on the equipotential, potential difference is not there. The electric field is always perpendicular to it. Electric field goes from higher potential to lower potential. Also, equipotential surface gives us the direction of the electric field, and equipotential surfaces, they can intersect each other. That will never be possible. Okay, just like fields can't intersect, even the equipotential surfaces can't intersect. So you can write some properties like no work done, or the field is always at a right angle. It gives us the direction of the electric field, and no equipotential surfaces can ever intersect. So an equipotential surface is where all the points have the same potential. All these important points you should mention. Relationship between field and potential. Basically, dV by dr, negative sign is electric field. Very important formula. Numericals also can come. This is another important thing. Okay, electric field is dV by dr with negative sign. It starts with the work done concept. Work is E dot dr. Okay, E dot dr. So start with that work done per unit charge. So this formula is also very, very important. Uh, Okay, next, define electric potential, already done. Sorry, equipotential surface is done. Define electric potential. Electric potential is the work done to bring a test charge from infinity to that point. So per unit charge, how much work you do is that potential. Expression for potential, you know, on an isolated point charge. So the formula is kq by r. Yes, kq by r, standard formula. Kq by distance. Again, you should remember this. Very, very important. Yeah. Yeah. So this is also important, guys. Then next important thing, derive the expression for potential energy of two charges and in the absence of external field. Again, very important formula over here. Let me show it to you. Yes, it is going to be nothing but K Q1 Q2 divided by R. This is the final formula for the potential energy of two charges. And you have to derive it by saying it is the work done to bring the charges from infinity to that separation of R. It starts from that. Yes, infinity to R. All these things are there. Then expression for capacitance, parallel plate capacitance, standard formula, definition, very, very important, guys. Please go through this entire derivation. I have also done this same derivation over here. All physics derivations in the same thing. Epsilon naught A by D, very important. Then obtain the expression for effective capacitance when connected in series and parallel. So in series, the total capacitance will be 1 by C1 plus 1 by C2. Charge is same, voltage is different. Series, charge is same, voltages are different. When you talk about parallel, the charges are different, voltages are same, and total capacitance is C1 plus C2. Both the derivations highly, highly important. Energy stored in a capacitor, half CV square, half Q square by C, half QV. Those are the formulas. The energy stored derivation starts from work done to move the charge across the voltage. So very important derivation. Again, I have done this in this particular session. Please go through this derivation if you want to pass. In current electricity, two factors on which resistance depends, and how does it depends on the length, etc. So it depends on basically the material, it depends on the length and also the cross section. It also depends on the temperature, because resistance is resistivity length by A, and also resistivity is a rho naught 1 plus alpha delta theta, where delta theta is the change in the temperature. So definitely it depends on the temperature, it depends on the nature of the material, temperature, area, and the length. So if you know these formulas, easily you can mention it. Resistance is directly proportional to length. Resistance is inversely proportional to area. As temperature increases, resistance increases. All these factors you can definitely mention it. Ohm's law and the limitations. Ohm's law is where when you apply a voltage difference, the current passing is directly proportional to the voltage. The ratio of the voltage and current is called the resistance, and it is measured in ohms. And what are the limitations? It is not applicable every time. So non-ohmic devices like diodes, semiconductors do not obey Ohm's law. Also, it is not valid for conductors at very low or very high temperatures because at very low or very high temperatures, they behave very differently. Like for very low temperatures, they become superconductors, and for very high temperatures, they melt, and many undesirable effects may happen. Also, the current and potential difference relation is not very unique, and you should know that the variation between current and potential difference is not linear every time. It is only for a decent range, but when you go for very high ranges, sometimes you will see some non-linearity occurring. So this is just for most of the cases, for most of the ranges, it works, but there are definitely limitations for semiconductors, very high temperatures, very low temperatures. For a very high range, it is not valid, and the graph is not necessarily unique, for voltage and current. All right. Then this is done. Derive the relationship. Derive the relationship J is equal to sigma into E. 100 times I have derived this. So guys, please go through this session again. Current density is sigma into the electric field. The relationship starts from V is equal to IR, and resistance is rho L by A. Current is current density uh, uh, into area, and the voltage, I can say, is electric field into the length. Electric field into the length. All these things you use, you will definitely get it. And sigma is conductivity, which is 1 by resistivity. So it starts from Ohm's law. You should know current density, resistivity, and voltage is related to electric field concept. From that, you can easily get this particular derivation. Same thing is there over here. Resistance and its SI unit. SI unit ohms, it is 1 volt per ampere, and basically you can say it is defined as the voltage difference which is created across the conductor per unit current passing through it. Similarly, resistivity, the unit of resistivity is ohm meter. It is a material specific property. It is a material specific property, and it can change with temperature as well as material. Okay, the resistance of that 1 meter length of 1 meter square cross section, that gives you the resistivity of unit length and unit cross section, that gives you the resistivity. Equivalent resistance, and explain Kirchhoff's law. Equivalent resistance means when you connect multiple resistance together, then whatever is the effective resistance gives me the total resistance, right? And for series, you can give an example. For series, it is R1 plus R2. For parallel, it is 1 by R1 plus 1 by R2 is 1 by R equivalent. For Kirchhoff's laws, there are two laws. One is the Kirchhoff's first rule for current. It is based on the conservation of charge. So the net current meeting at a point is 0. And the second rule is based on the conservation of energy, called as the Kirchhoff's voltage law. So the total voltage drops across a closed loop is always going to be 0. These two important laws, again, very important. Derive the expression for conductivity. We have again derived this many times. So I have put the derivation over here. Obviously, I have solved the same derivation in this particular session as well. So it starts from the drift speed concept. Also, the concept of current density is involved, and also you have to involve the concept of electric field, how it is related to your voltage. Remember, voltage by length is electric field. dV by dr is electric field with negative sign. Magnitude wise, E by L is equal to voltage. All those concepts will be needed over here. Drift speed, relaxation time, and the expression. Standard formula, standard derivations, hundreds of times we have done this. Again, in the same derivation class, please go through it. This is again a very important derivation, guys. Okay, drift speed is E by M into relaxation time. Relaxation time is the time between successive collisions. Keep that in mind. Two cells are there in series and then in parallel. Find the equivalent EMF. Yes, you have to derive this using Kirchhoff's voltage law. When you connect them in series, effective EMF is E1 plus E2 and effective resistance is just R1 plus R2. Okay. Similarly, when you have two EMFs in parallel, then the effective EMF is given by 1 to E1 R2 2 1 E2 R1 upon R1 plus R2, whereas effective resistance R1 R2 by R1 plus R2. These two formulas, if you remember, you have to apply Kirchhoff's voltage law in this particular loop, which has two batteries in parallel. That's it. That will give you the answer. For the balancing condition of Wheatstone, 4 resistors, you connect a resistor in between, no current will pass. So to balance that, what is the formula? Again, it starts from Kirchhoff's law. Remember this. And the final formula for that is R1 by R2. I think it is not visible here, but it is R1 by R2 is R3 by R4. So if this resistance by this resistance is this by this, no current will flow here. That is the balancing condition. Use Kirchhoff's law. Check out the derivation again in the derivation lecture. What is a potentiometer? Give the principle and uses of application of potentiometer. I think this is not there. Ignore this. Sorry, guys. Ignore. Yeah, that's about it. Yeah. So these were the questions which are very, very important for your passing in your second PUC physics examination. Mainly, you can see many derivations are there. Now, numerical questions, there is a separate session tomorrow. This entire PDF will share it with you so that you can practice these questions. But please, please, please go through all the definitions and all the things which have been mentioned. Okay. Practice it 2-3 times. So in the exam, you will not find it difficult. Most of them are derivations. Keep that in mind. And the next of them are numericals. Very few properties are there, but diagrams are there, graphs are there. You should know that. Cool. Have a great time, guys. Take care.